All right. Well, welcome everyone to the April 25th Resource Management Working Group meeting. I have two topics on today's agenda, as well as some special guests from, sig-scheduling and sig instrumentation. So thank you. First up on the agenda was talking about feedback of the testing work. So I guess, Bala, do you want to talk through that?
Sure. Let me share my screen so that I can give some context on this. So this is the document. I don't have any slides, so when we met for the latest face-to-face meeting on resource management working group, we agreed to prioritize building some kind of a node performance benchmarking framework so that we could test or benchmark some of the node performance features that people are planning to add in the Kubernetes ecosystem, and have some objective data on it. So main reason is there are some low-level optimizations or performance optimizations that people are planning to add in the kubelet, and we wanted to have a way to objectively measure the performance of these workloads with and without the feature enabled, for example. That's what this proposal is about. So there are mainly three parts to this proposal. Or three components to this proposal. The first part is the provisioner itself, as in like provision a Kubernetes cluster. It could be on GCP, AWS, or bare metal, or any other platform. The second part is the test runner itself. How are we going to run the test? The third part is the result aggregator and graph plotter or result plotter. So there are several options for these. So what we did was we took some of these options. We discussed this proposal with the SIG testing community, and the initial proposal, I think it is discussed at the end here, where we have a roadmap. For phase one, what we are planning to do is add this test runner to the node E2E subdirectory within Kubernetes or core Kubernetes, and leverage test infra as much as possible. We discussed the same option with SIG testing. There were RNC, one person from Red Hat and another person from and Tim Sinclair. So they were the ones who are giving us main feedback, and they think this is a good idea. So this will be similar to the make target for node E2E. I forget the make target, which is, I think it's node E2E test. So it'll be similar to, yeah.
Can I interject and ask a question, or
sure?
We wait till then.
No, you can ask me questions.
Okay. I wonder why we're choosing the node E2E instead of the cluster level E2E, because there could be example workloads that we're running which span more than a single node. Like that, for example, network is also a thing that we want to measure.
Right. We wanted to keep it simple for a start. This is going to be, for a start, it's going to be single node or target single node workloads. We're going to test the performance of running workloads on a single node for a start.
Okay. The other reason why I mentioned that is because you can do single node even in a cluster level test.
Okay.
You can, if all you want to run is like a single instance of your workload and it doesn't span more than a single node, that is still possible.
Okay, that makes sense. Okay, maybe we can explore that option too. So the one of the options that we are exploring is just leverage the E2E infrastructure that is already in place in test infra, and then publish the results. So in case of, I don't know if people have seen this, there is one more node perf dash, but I don't think, yeah. So node perf dash has some kind of result aggregation and graph plotting. Not sure why it's not loading. So it has a set of graphs published there with respect to like pod creation latency, CPU usage, some of the metrics. So we want to do something similar for a start with single node runs. The workloads that we are discussing is something Connor and I have been working on. So I don't know if this is visible to everyone, but we did some preliminary benchmarking for the CPU manager with and without the CPU manager feature. We have some initial results for some workloads which are like kernels that perform some scientific operations. So we have some initial results from there. We also are currently working on getting results on neural network training. So I have some Docker images here, but this is still pending. So we want to add these workloads for a start. This framework that we are trying to build will also be extendable with other workloads. At least that's the plan. For a start, what we are trying to do is make something minimal where it's pretty simple, where we use the existing mechanisms to provision something on GCP, run the tests using existing mechanisms such as test infra, and then somehow plot it. At least that's the first phase. So like Vish mentioned, maybe we can look at cluster level test as well for even the first phase, because if you can run single node tests there, that'll be useful, and we can expand it later on to cluster level test.
Yeah, I mean, that sounds awesome. I think once we have a framework where people can add different workloads as examples, and if you literally have a small walkthrough guide that says how you have to add a new as a benchmark, then I think we can crowdsource this and have like much more workloads, like sample workloads that we can run tests against.
Right. At least that's the plan. So we'll have docs, and I'll put out all the Docker images, Docker files as well, so that we can have it all documented, and Docker files, pod YAMLs, whatever is required to run the tests, and extensive documentation on using these frameworks and how to add new workloads.
Okay, so where would, like, logistical question, where would these artifacts reside?
So we were initially thinking the test runner, whatever is running could run and could be staged in like E2E perf or something like that.
Okay.
Test runner, and the code. So Docker files, the pod YAMLs could be staged in like perf test or something, and then we'll link these two things together with some documentation. But we can just say, this is the Docker image that we are running, but the Docker file is in perf test, or we can host that all of these things together in perf as well.
Yeah, I think that makes sense. I recently tried to set up Kubernetes end-to-end tests out of tree, and that was a huge pain. That doesn't mean it's actually painful, and maybe I was missing some easy hacks, but I spent a lot of time just trying to get end-to-end tests working outside of, or like developing end-to-end tests outside of core Kubernetes repository. So it probably makes sense to start there.
Okay.
Test that.
Okay, but initially we are just trying to use whatever mechanism is already provided. Like for Node E2E, just deploys a machine in GCP. So that's what we are going to try to do. But later on, we can try to make it work on wherever, like localhost also, wherever.
Okay. Yeah, I mean, in general, like the cluster level E2E framework is already running across different environments. And I think like CNCF is also like launched a new blog post recently where they show that they have a dashboard where they're running the end-to-end tests across different environments. Yeah, there you go.
Yeah, that's the other thing. That's the other option we are exploring. But this comes under the provisioner part, where provisioner component where we can provision Kubernetes clusters on different platforms.
Okay, but in this case, like I'm assuming we wouldn't care about provisioning, because all we are doing is like deploying workloads that are already supported by Kubernetes in like beta or above APIs.
Right. I mean, the test runner part, only you can point the test runner part to any Kubernetes cluster and it'll just run some tests. But but
Okay.
at a later phases, we can provision the cluster wherever we want. As in, it could be anywhere.
Okay. Did you check if E2E node is also run across environments?
Yeah, so I have some experience running it on GCP and AWS, like just running manually the E2E test while I was working for CPU manager E2E test, Node E2E, so it works. Not only does it work in the CI/CD environment within Kubernetes, it also works in your own GCP cluster and AWS cluster also.
Yeah, I mean, Red Hat pushes test ED node results from RHEL on AWS every 15 minutes or 2 hours, I forget, into the test grid.
Okay, that's awesome. The reason I was asking is because if the cluster level tests already have enough infrastructure to run across different environments, then that might be another reason why we might want to choose a cluster level ones. But if Node E2E is in feature parity with cluster level tests, then we can totally start with node level tests for now.
Okay, I'll make a note of this and I'll explore that option too. I'll look at both cluster level tests and I mean Node E2E works for single node right now, and anybody can run it in their own environment as well. But I'll check the cluster level tests.
Yeah, I have a preference that we start with Node EDE, and the cluster one to me is more interesting when you want to do stuff with storage, and I don't know if that's like in the domain of this problem domain.
It is and it is not direct. The problem is, let's say you have local SSDs and you get into like PCI mapping for local SSDs, or like let's say you have network interface cards and like CPU topology is important for them. And in that sense, like you'll have to start monitoring network performance as well. And for that, you need to run across multiple nodes, maybe not for the storage case, but for the network one. So
Yeah, I don't disagree. I guess it's like which test does one want to tackle first, and then network would be very dependent on like the SDN choice you make, and that don't really feel like that's something that we should at least this group doesn't need to focus on. Maybe others feel otherwise, but I think it's like outside of our domain.
no, I agree. I think the way I was thinking of this is that like we have a generic framework that can be consumed by different people, where like the domain expertise might change, but we rather collaborate as an overall community and derive value through this. So
but like networking in particular, like not all SDN solutions are delivered through the Cube core, right? So then like you get into like a weird community management problem of how do I want to present my networking SDN in these tests.
But having the data would be useful, right? Do you disagree with that?
No disagreement. It's just the management overhead, and then like whoever would be signing up for this would be signing up to answer a lot of questions that might get uncomfortable.
Okay, fair enough. Okay, so I mean, to be clear, like I don't have any specific objections to doing at the node level. I just want us to have a framework that would require low maintenance over time. And so if you're investing a month or two getting Node E2E to work, and then we have to reinvest that for the cluster level, then that might not be ideal. But in any case, I'd be Balaji to make that choice. He has gone through all of these pros and cons.
Yeah, I'll also explore the cluster test and report back. So the feedback from SIG testing was they were fine with this plan. We need their support because we might need to make some changes in test infra. Ideally, we wouldn't want to make any changes, and you just add the test as a periodic job, and then it'll be done. But if we need some additional features, we can add it there too. So, so do we need to like take this to sig-node as well and present it there, or is this community fine? Or I'll report back to our resource management working group every 2 weeks to 4 weeks.
Do you have do you need additional help here?
So that is I don't know yet. Let me start working on it, and only then I know.
Okay. So I think for your question though, like, I mean, sig-node will be the owning sig to maintain this test health, I assume. And so, I mean, personally, I'm not too upset if you don't, like, I'd like to avoid you having to repeat yourself, but like, we should just make sure it's on the planning document that Dawn and I had circulated, and then if people want to link out to what you have here is fine. But like, this does become like a long-term ownership project for sig-node. So,
Derek, is that true? Though?
Okay.
Conceivably, there could be different performance tests, some of which are owned by SIG storage, for example, some of which owned by SIG network, for example. The framework, depending on whether it lands in Node E2E or cluster level tests, it might become part of sig-node or SIG testing. Ideally, like whichever test framework it is, it should be part of SIG testing. So I feel like this might be something that is actually per test case rather than the overall suite as such.
yeah, like if you had a way of structuring, I hate that like political structures need to then bleed into code structures, but like if there was a way of differentiating like the framework from like the actual test, and then having an owner's file that associated the one test with the right people and the right sig, that's probably good. But I mean, from a sig-node perspective, I feel that like we want to know if CPU manager is working well across releases. So like the testing information is critical. And I mean, I have no objections to it. I would struggle to believe anyone in the rest of the sig-node community. I mean, Vish, you have no objections. So this is all net positive to me. But yeah, I think it might be on a per test basis who owns long-term test health.
I think we already have like test management is now based on regular expressions, so like more fancy strings to filter out these tests, I guess.
Except for merging, it's still based on owners files for merging.
That's fair, and now we have a per sig directory for tests, right? So the tests can be distributed, but then when they run together, it's still based on those Ginkgo regular expressions. So.
Yep.
Yeah. Anyways, I was just raising that there is this alternate perspective to look at this. I don't mean to block progress.
I can actually do this presentation in sig-node as well, just to get them also on the same page. It's not a problem, and yeah, I'll continue reporting back here as well.
Okay. So Dawn pointed out that there was this group called Kasten. I forget the name. I might be saying it incorrectly, but they were also trying to do something similar last year. Did you?
Is from the Kai Cloud. I haven't been able to get in touch with them. That thread got cut off. Okay. Maybe I can reach back to them again, and then we'll see where that takes us.
Okay. Awesome.
Okay. Well, thanks, Balaji. And if there's no other questions, I guess we can move on to the next agenda item. So I think the next agenda item represents like what I think this working group should figure out best, which is try to get answers to unclear technical choices that span SIGs. So I guess Sally and Frederick, you guys had put together a brief document on like what you felt SIG instrumentation would like with respect to monitoring, at least device plugin monitoring. Do you guys want to walk?
Sure. You want me to share my screen here?
That's probably best.
Let me see if I can get it actually working properly. All right, can you guys all see my screen here?
Yep.
All right, awesome. So kind of the key objectives we wanted here were that we wanted to make metrics less centralized through the kubelet and through cAdvisor. We wanted to avoid having kubelet need to do any augmentation of metrics because we don't want kubelet as the bottleneck. We knew we needed to have some stable, well-defined set of metrics because there's components that obviously depend on these metrics being there and having certain names and semantics. And we wanted to make it so that Prometheus-speaking components can easily correct metrics, because in addition to just Prometheus itself, which obviously has a large mind share in the Kubernetes community, there are many other tools that kind of speak the Prometheus transport format. And so enabling those tools to also be able to easily collect these metrics, as opposed to having to write bespoke ingestion mechanisms to understand some sort of custom API, was the goal as well.
Can I ask some clarifying questions? And I know I didn't get much time to talk about any of this before the call, but like when you say the kubelet does not have to do any augmentation of metrics, can you speak to what you mean by that?
Yeah, sure. So the idea here is that metrics from each individual component should stand on their own. So the kubelet should not have to add any data to other components' metrics, right? So like if I, for instance, wanted to point my monitoring tool directly at a device plugin, or the pod in which a device plugin ran, or if I wanted to point my monitoring tool directly at, say, a CRI implementation or something of the sort, right? Like it should be able to understand, should be able to have enough data with those metrics to understand them. And the kubelet should not have to add any information, or should not be adding information to those metrics themselves. So everything stand on its own, kind of.
I guess that's debatable, right? So I just want to like tease on this one a little bit more before we like. I want to make sure everyone actually like agrees on that requirement, because I think it's. I don't know if I agree with it yet.
Okay.
So, like, do you have an example of a metric you feel like the kubelet is doing that today that it shouldn't have been doing it with?
Can I ask a question?
Yeah, go ahead.
On Solly's statement. So Solly, like, is it fair to say that you're saying that kubelet should not be in the data path for collecting metrics, but it's okay for kubelet to be in the control plane path for making sure that these external entities have the necessary metadata in order for them to expose metrics?
Yeah, kubelet. I think we can discuss how the appropriate data gets to the individual components later on, because that was a point of discussion. But the components should be given sufficient information to expose these metrics, or have some way to get sufficient information to expose those metrics with the right labels, right? So like let's look at a concrete example, for instance. Hold on, give me a moment. I need to stop sharing my screen for a moment.
And then to make sure I understand your question as Sally's finding out more data, Vish, when you're separating the control plane versus data plane argument there, is that saying, is it okay for the third-party component to have to call back to the kubelet to get the enriching data, and therefore it's in the control plane path, but not necessarily the data collection path?
All right.
Is that a right way of phrasing or thinking about your question? Vish?
Derek, or to...
Yeah, Vish, I guess I'm trying to make sure I understand when you say within the control plane path versus the data plane path. Like,
the thing is, like, kubelet has information that external entities don't. So kubelet has to play some role in monitoring, but as long as that role is not in the data plane path, which it is currently today, it feels like a big win to me. But I wasn't sure what Solly meant by kubelet not being in the path at all. So that's why I was actually like, it was more of a question on Solly on
so
what he meant by that.
So like ideally, right, in my mind, components would either be given or have some way of obtaining all the necessary information, right? So like if you have, say like the CRI, right? The CRI plugin, the CRI implementations actually, as far as I can tell, get enough information about the name of the pod that a particular container belongs to through the pod sandbox metadata to be able to label any given metric about a container with the container name, the pod name, and the namespace to which that belongs to, right? And so that information, so when the CRI implementation exposes a metric, say CPU usage, it should expose it with those labels and not, say, rely on being proxied through the kubelet and then having the kubelet say, oh, this is container ID, blah, 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 so I need to attach pod name and namespace name to it. Does that make sense?
There are a lot of, but there are a lot of components right now which don't have that information. Device plugins don't have any of that.
Yes, and I would argue either we need to find a way for the kubelet to expose that information so that device plugins can get it, or the device plugin API needs to be given the information to allow it to expose that information.
So this is not just device plugins, right? I would imagine volume plugins wanting something similar, and say network plugins also wanting something similar. Like it's just a question of like there are so many resources, both logical and physical, that a given node is comprised of, and like Kubernetes needs to get out of the way of collecting metrics for all these logical and physical.
I mean, I think some of those APIs already have that information. I know device plugins doesn't, but I thought a couple of the component APIs actually provided sufficient information there.
I doubt that network plugins actually do.
It's a little hard to hear you, Vish.
Yeah, you're really quiet.
Sorry, I'll probably like try getting closer to my mic. So network CNI plugins don't offer enough metadata to map a given network to a pod. Neither does device plugins, like I said. I'm not sure about CSI and like the volume plugins interface.
I thought CSI might have last time I looked at this, but I could be misremembering.
I thought CSI has that information because CSI is supposed to be container orchestration to.
So I guess though, like, what is the operational benefit or the end user benefit that justifies the requirement? So there are a couple benefits to this in my mind. One of them is that you don't have the kubelet as a bottleneck for metrics collection. If you, for instance, want to point your metrics collection software at all of these individually so that it can monitor whether metrics collection succeeded or failed individually on a per component basis, you have that. It means that you don't have any extra work basically going on in the kubelet more than is needed. It eliminates potential sets of bugs where, like, the container runtime thought one thing, or the component thought one thing based on the information it had, and maybe the kubelet had a slightly newer set of information, and so it accidentally attached the wrong set of labels. Like that, those kind of bugs don't happen because all the identity information is being attached together. So, you know, if the device plugin receives the information that says this is for container X in pod Y and namespace Z, then those are the labels that are attached at that point, and so you have the kind of a holistic snapshot of information there.
It would also mean that the information basically leaks into the kubelet, where the kubelet needs to know based on which labels what kind of information to collect, and then we end up with a similar situation. It's not quite as bad, but similar to how C-Advisor is compiled into the kubelet today, only that we have application-specific logic to add additional metadata. And that's basically what we're trying to avoid here, right?
Yeah, that's a good point as well.
I think it, like, requiring all the APIs, like, for example, requiring the device plugin API expose this information, the pod ID and the namespace information may not be correct. Like, there may be some other reasons where because of what we don't want to expose this information, right? Like, there may be APIs where, like, for example, device in the device plugin API, we have been holding exposing this information because we kind of don't want to because of some other reasons, right? So requiring that the monitoring pipeline will only work if you expose this information may not be like the best thing.
So I think the tension here is that we want the plugins to do as minimal stuff as possible, as in like have a really well-defined scope that is easy to reason, and that way we can have some reasonable conformance and portability across environments, for example. On the other hand, for monitoring and introspection and tracing, you would need as much information as you can get. So that's sort of why I was asking initially if Kubernetes can do just minimal amount of work such that it enables literally every possible extension around instrumentation, like whether it's monitoring or logging or tracing.
I mean, I know in the past there has been some discussion of exposing some sort of like pod identity API or something off of the kubelet so that things running on the node could do associations with different pod identities. I'm not personally a huge fan of that approach, but it could be one solution to this.
So I have a question. Is the discussion right now to get the container pod node mapping from device plugin, like to add that capability to the device plugin? The device plugin can handle the monitoring pipeline outside of the kubelet?
So I think the device plugin in this case is just one potential plugin. I think the discussion here is like, is this a path forward for all plugin types? Or,
yeah, it's kind of supposed to be a broader, like things that run on the node alongside the kubelet and the kubelet itself.
How is that information can be exposed through like any plugin, not just device plugin? Because right now, like you guys said, this information doesn't exist, and there's this may be one of the solution to decouple metrics from kubelet. But how is this possible?
I mean, I think that's kind of what we're discussing right now.
Okay.
Yeah, so if people agreed with this requirement, then obviously changes would need to be made to the plugin points. I mean, I agree with Sally on the CRI front that like people that are running container runtimes are going to monitor those container runtimes separately from the kubelet itself. And at least for CRI runtimes that would be running out of tree, if that would be containerd or cryo or I don't know, the list that keeps growing. Like production deployments of those would still monitor that container runtime, and then I agree that the container runtimes have sufficient data to map usage information to the pod and container boundary. It's just the question of like, is that having to be done for every third party or not? And I appreciate Vish's concern about it growing the scope of the plugin space. I also appreciate the desire to not have the kubelet be the bottleneck, I guess.
Yeah, I mean, it's really about like avoiding the kubelet as a bottleneck and avoiding having more custom logic in the kubelet to do, you know, like, oh, for device plugins, we always need to add this information, or we usually need to add this information. For you know, network plugins, we need to add this information. For storage plugins, we need to add this information before it expose it. You know, it also, like, if we need to add extra information in the kubelet, it also means that if something were to, like, if you were sitting around and trying to debug a particular component and you wanted to just hit metrics for that component, you, like, the metrics wouldn't be useful to you until they had been processed by the kubelet.
So I'm trying to rationalize, like, at what level of granularity is the right level of granularity. So, like, if I think about sig-advisor today, sig-advisor tries to couple both knowledge of the container and its usage stats along with, like, the file system and its corresponding usage. And so basically it's working at like a container boundary. When you start talking like at the device boundary, you're getting to like a sub-level below the container. And I'm wondering like if that's the tension that's like a step too far for individuals on the call, or are people basically saying like the right boundary to stop things at is at the container boundary?
I don't think we may want to limit the design at the device level, because currently device plugin is only supposed like integer resource. But if in the future it's possible to share device or anything like just limit at the device level, may have some limitation. And also, if people want to export device level metrics, they don't have to be associated with the container or pod. Right?
I think they would be. So I guess my impression of the proposal is that it focuses mostly on like how and what the metrics look like and sort of format and stuff, and doesn't necessarily cover very much of like how different things are going to get the metadata. I am working on that, and things are still in progress. But in terms of abstraction, I think that to Derek's point, I think the right level is going to depend on the metric being collected. And I like a model like this where it's flexible enough that anyone can sort of attach metrics to a pod or container in that way.
Yeah, I mean, kind of the goal here, right, is like you as a device plugin writer or as a plugin writer or as a component writer you are given enough information to make the associations that you might need to make, right? And you can choose to expose those however you would like, right? Like if you want to expose information broken down by pod and pod container, but you also want to expose information by device in general or something, because the device is like shared across different container pods or something, like, right, you can choose to do that based on what metrics you expose, right? You have all the information you need, and you can choose what metrics. We don't prescribe like what metrics here you expose. It's just that you should attach things in ways that make sense.
So to actually confirm with what you just said and give a data points for NVIDIA GPUs, we currently don't have a way to give you metrics per container. Even if we have the association of this device is shared with these two containers. Right now, devices are exclusive to containers, but we don't have a way to give you that information. So this is how we would use it. Right now, we would not be able to give you metrics per container. But we would be able to, because of the exclusivity, we would be able to give it to you. But if GPUs starts getting shared, we would not be able to give you that information.
But that becomes the decision of the device vendor itself then to decide, right? So if you start treating like the device as virtualized to some degree and you can do that split, then yes, you would need to figure out a way to provide pod and container metrics with that in mind. But like if you're a device vendor who knows that your devices are handed out exclusively, then you could also still provide pod and container metrics. And then I guess the kubelet today is very strongly assuming for accelerator stats that it is exclusive and container scoped.
Yeah, and so by moving this decision out into the specific, like, I would like to have monitoring decisions moved as close to the people who have the best idea about what's actually going on, right? Like, kubelet cannot have the best idea about everything that's going on, right? Because that's the problem with sig-advisor, right? Like, we're trying to put all the logic for everything, knowing everything in one place, right? Whereas, like, NVIDIA presumably knows how they have written their device plugin the best, and what the associations are, and what the constraints are around that system, and what the corner cases are, and whatnot. And so by saying, okay, NVIDIA, here's the information that you need to make the associations potentially between device and pod, make the decisions that make the best sense for the NVIDIA device plugin, and expose the metrics that make the most sense with the associations that make the most sense. And we in the kubelet don't need to know NVIDIA GPUs work like this and have these associations. We leave that off to NVIDIA to make that decision.
Yep, I agree on that part. I just wanted to give a data point in terms of how it would be used.
Okay, I mean, yeah, that's definitely good to have. It's good to have that data. It's always good to have more data. So.
Given that we are also discussing perhaps in network and storage, they also have similar requirements. I feel we perhaps also should loop in some folks from CNI and CSI to see whether they have any special requirements in that area. Like, for example, I think a CSI, they are not tied to Kubernetes, and I don't think they can understand pod concept. So I don't know whether they have any other requirement.
So on a different conversation, I do want to bring up what was brought in that document, and that one of the things we would like also to be able to do is have a monitoring container. And so that was the issue we were facing, and that maybe we do need that association in the device plugin API to have container and pod and device mapping, but it becomes complex at that point if we want to have a separate sidecar container, monitoring container, to use the device plugin API.
So yeah, I mean, this was. I feel like this is kind of an implementation detail. I feel like it's an important implementation detail, but like I feel there's a difference between here, and I do want to discuss what you're saying. Agreeing that like we should have like each component and exposing like metrics that are already appropriately labeled, and between figuring out how we get that information there, whether or not it's pushed through the APIs or whether or not kubelet exposes some sort of API for doing associations or something like that, right? Like, so are people on board with the general concept of having like the metrics exposed by each component already associated without having to go through the kubelet? Are people on board with that?
The issue I would say that was a concern I raised in that doc was just how like it would be important for me running production clusters to know that the source and target for my metrics are both mutually trusted, and then how easy it is to get that mutual trust in the world presented here. And I think you noted about a potential proxy.
Yeah, so I mean, in terms of authentication, we can jump ahead a little bit here. In terms of authentication, there's basically two options that we kind of thought about. The option I prefer, because it leaves things still more aggregated, is there are actually several kind of authenticating proxies, and we use them extensively in OpenShift, for instance. And we could probably use a trimmed down version of one of these that basically are designed to sit in front of APIs and provide Kubernetes authentication, right? So they know how to do token-based webhook and certificate-based webhook RBAC and authentication, and so they can provide that for you even if you don't already natively support that, and then consumers could just use the normal Kubernetes mechanisms that they're used to using, right? And you could write Kubernetes RBAC rules about, okay, such and such user or such and such a component is allowed to collect node metrics for any component, any node component, or such and such a thing is allowed to collect node metrics only about this particular device plugin, or only from the CRI, or whatever. And so you either build that functionality in using Kubernetes Go libraries, or you run one of these little proxies as a sidecar container in front of, alongside your, alongside that, as one of the containers in the daemon set that you're using to run your device plugin or whatever. Does that make sense?
Do you think if this requirement may make it hard for vendors to develop their device plugins? I think, as Vish mentioned, one of the goal for device plugin to make it easy for vendors to export their resources on Kubernetes.
I mean, I think that to me is like the goal of of adding the proxy, of having the proxy, right? Like having the easy to consume proxy is you don't have to choose to write in Kubernetes specific integration in terms of auth. You don't have to deal with all the Kubernetes auth. You just drop this. You only like the way it works for a lot of the components that we use in OpenShift, for instance, is that you have them listen on localhost in the pod. And then you have the proxy, bind to all addresses or whatever. And the proxy just sits at the port that normally the thing would be monitoring at and intercepts all requests and says, does it have a particular does it have the appropriate token header? It goes and makes the RBAC call for you if you turn on making RBAC calls. And then if everything's copacetic, it passes the request through to wherever you told it to pass the request through. In this case, generally, localhost and some port. And so, if you want to meet this requirement, you just drop the proxy in place, and it's relatively simple.
So this proxy will run as a sidecar container? Or
it's just a sidecar container that you run.
I can't hear you, Vish. I think
you're super quiet.
Okay. Hold on, I'm going to switch. Can you guys hear me now?
Yeah.
So I was just saying, I think we have discussed this in great lengths now. And I think there's a general agreement that we want to decouple monitoring from the kubelet. And I felt like there's overall overwhelming agreement on that. The piece that is still contentious is how does kubelet expose the necessary metadata for a wide variety of use cases? Can I propose tackling just that as a separate item? And there are a few folks in this call who have already spent some time on that. So maybe you all can work together with a doc or chat or whatever, and then maybe we can discuss this again in the next meeting.
Vish, sorry there's one question that I wanted to know about is how do you do endpoint discovery in your model?
How do you do what?
It's not, well, how's the endpoint discovery done here in that model? Sorry.
So there are a few options here. I kind of left that, I think, a little bit vague in the document. But I think presumably something like an annotation on the appropriate pods or on a service object would be relevant, or it would be reasonable, or even create a CRD that just is like node monitoring object CRD, right? And you just specify the port and whatever the details to connect to on each node, and then something that, once you get that, then you
Sorry, I think
Frank, though, Renaud, like, we're talking about endpoint discovery of metrics that are not core to Kubernetes, right? And so, like, it's not a requirement of Kubernetes to know how to discover these endpoints, right? It's just a requirement of whatever monitoring platform you're deploying to know how to discover them.
Exactly. Like we could, hypothetically, you could also use Prometheus service monitors from the Prometheus operator, right? Like I kind of left that open, but there's a number of options that we can do that kind of fall under kind of some standard Kubernetes. How do we do endpoint discovery in Kubernetes in general?
The tension here to me is how we get things out of the core monitoring pipeline that should never have been in the core monitoring pipeline.
I think the summary API was never meant to be just the core monitoring pipeline. It was meant to be this placeholder until we have this alternate pipeline. So like I was saying earlier, I think the discussion has now boiled down to the specifics of how the summary API would be moved out of the kubelet, and like how kubelet would empower other third-party plugins to expose the right set of metrics. I feel like there many different ideas were discussed, but it would be very useful, at least for me, if those ideas are captured in a doc and probably shared with everyone, so that we talked a lot of interesting points here, but I'm not sure whether all those were captured, and I wonder if we'll like go through the same thought process again.
So I have no disagreement that figuring out the way by which the kubelet could make this information known to third parties is the obvious next step, I think. But I do think it was very beneficial to at least have this discussion to understand that, like, being able to get metrics delivered from the author as close as possible seems to be like a pretty uniform agreement across the group here, right? So
yeah, I mean, we want to enable that, but at the end of the day, there's going to be like so many different monitoring solutions as it's been the case for a long time. So each monitoring solution might make its own constraints. So in that, like, I feel we should probably not be opinionated on the fact that monitoring has to be distributed, but that seems to be like the most extreme case. And if we work for that, then the rest of the things should ideally work.
Yeah. So, I mean, like, if we say monitoring should be distributed, or we design a system where monitoring can be distributed, and then someone chooses to implement all of these constraints on top of Z-Advisor, like, that is their prerogative, right? But as long as we have a sufficiently flexible system where people can and try to write this like distributed monitoring, like non-distributed monitoring should just strictly be a subset of that. It should fall into place.
Yep, agreed.
There was, if we have a little bit more time, we have like 4 more minutes. There was one other thing that I wanted to discuss apart from the things that we need to discuss in more detail, which was kind of a conversation that David and I were having around versioning in of metrics and how we deal with guarantees. So I had kind of imagined this system in which you basically document names and semantics and say you always have to implement these metrics. You may choose to implement these metrics, but if you do, we have semantics that we say, like if you implement network TX, that's always network transmitted bytes. And if you're going to implement network transmitted bytes, give it the network TX name, right? And then there's like a third class of metrics, which are just whatever. Like they're specific to vendors. They don't necessarily have guarantees about changing them around them. And those would be kind of exposed together, but we would have a versioned endpoint that would guarantee for a given set of like guaranteed metrics and known metrics to always have that same set. And the tension was kind of between that model and just calling those supplementary metrics alpha. My concern with that was mainly that alpha and beta imply progression, right? Like it doesn't make a ton of sense to me to have certain metrics as alpha level and just have them alpha forever, because it seems like like the terms alpha and beta or whatever imply that eventually any alpha metric will become stable. And I think there's always going to be metrics that we don't want to guarantee, or we can't know the entire set of metrics, right? We don't know what metrics NVIDIA is going to choose to expose. We don't know what metrics certain CRIs might choose to expose. So we want to kind of have this class of metrics where we don't make any guarantees about them. They're there, but they're never going to become stable. But they're not alpha because they're not going to become beta.
Solly, when you say we, are we like big instrumentation or this working group? Or when you say we, do you mean like, in your example, NVIDIA with their device monitoring agent? Like,
which
community aren't going to guarantee that a metric exists or not, depending on whose plugins you're using or how your monitoring is set up?
Yeah, I was kind of using like we as like the broader Kubernetes developers, right? Okay. Like we as Kubernetes developers are not necessarily going to say NVIDIA always has, we're not going to know what metrics NVIDIA is going to have. And we don't, I think that we shouldn't try to prescribe what metrics NVIDIA has. But I do think it's valuable, especially in the case of things like CRI, to say, all right, you might not expose networking metrics, but if you do, you should expose them like this. You should expose, like, these ones you should expose like this so that people can have some reasonable confidence in consuming them. And you're free to expose other ones as well, but you always should expose CPU and memory because we need to use them elsewhere. You may choose to expose network, these types of network, this is just name starting example. I'm not saying specific ones. You may choose to expose network because people find that useful, and if you do, you should expose it like with these names because people want reasonable confidence. But then there's always this third class of metrics that's like specific to NVIDIA or specific to Containerd or specific to Cryo that are just extra metrics that might be useful for people consuming Cryo or consuming NVIDIA stuff, but are not necessarily shared amongst all device plugins, for instance.
Yeah, so I think I think we're closer than maybe we originally seen. I was thinking of it more from the perspective of, say, a device monitoring agent maintainer, that even though a certain metric may not be available in all deployments, that if you run this particular monitoring agent, then certain metrics are alpha versus GA versus. So I was thinking more from that perspective. I do agree that it's useful for us as a community to keep a list of known metrics so that if I'm, for example, implementing a new CRI runtime and I want to expose the same metrics as others, I can go to some place and see how I should name it. I think that's certainly useful. But I do still think, and I don't want to spend too much more time here because I'm not sure how many other people are interested. I do still think, though, that it's useful to be able to say, this is an endpoint that we do plan to change in the future versus this is one that's pretty much going to stay stable. And you should build on top of it.
Yeah, I mean, like, Prometheus offers no versioning as I can know. So having at least recommending, if not mandating, like just recommending some naming schema such that the monitoring experience is consistent across plugins in a Kubernetes environment would probably help most of the operators.
I mean, we do
develop subconscious naming patterns.
We do already have that to a certain extent. It's not universally followed. The biggest individual component that doesn't follow it is actually sig-advisor. But we do have instrumentation guidelines that all Kubernetes components are supposed to follow that prescribe metric naming, label semantics, when to use what labels, when not to use certain labels. For instance, never use the UID label, and stuff like that. And so that's...
Is that because sig-advisor was sort of grandfathered in? Like, sig-advisor having Prometheus integration like 3 years back before SIG instrumentation existed.
Yeah, so it's because sig-advisor was grandfathered in, and because I believe we weren't sure like whether we could reasonably change all the metric names in sig-advisor all of a sudden, without like causing issues for people.
Without versioning, it's hard for people to adjust.
Exactly. And
In
so
the interest of time, I guess we can like litigate history, but I'm worried that my laptop battery is about to die, and if I don't hit stop on the recording, the meeting will be lost forever. But I wanted to thank Sally and Frederick for putting this information out and like joining the call today. And then like it sounds like the next step that I hear is that we need to like come to some consensus on like the set of options that are worth exploring for making the information available from the kubelet. And it sounds like, Vish, it sounded like on the Google side, maybe there were some options that had been explored but not yet shared with the broader community. And if so, who wants to take that next step to like share that discussion so we can make a next step?
I can share that discussion. Is there anyone who would like to be a part of it? And then I will present it next week.
Yes. I think, David, I would love to see that as well. And I very much appreciate you doing that. And but I am going to hit stop and end the meeting if that's okay. So literally my laptop does not die and I feel rude to everybody. So
we can also like figure this out over Slack.
Yeah.
Okay. All right. Well, thanks again, Sally and Frederick and Balaji for presenting today. And it's really appreciated. And we'll be in touch in the next meeting.
Yeah. Progress is awesome.
Thank you, guys.
Thank you.